Welcome again. So in the previous video we have seen that if a particle is thrown with a velocity u making an angle alpha, and this is the aim or the target where it want to reach, it have to reach. So the maximum height is the capital H, it is called the maximum height. It will reach there, and how it will reach there? The maximum height will be attained by the particle due to the vertical component of motion, that is the vertical component of motion, that is u sine alpha. Okay, and so due to the u sine alpha it will be here, and due to u cos alpha, that is the horizontal component, it will be here. Okay, so due to the composite motion of these two, it will be here. In the previous lecture we have seen. After that it is again coming down, and u cos alpha is continuously pushing it towards it. It is coming down, u cos alpha pushing it, cos alpha coming down, pushing it. So u sine alpha is increasing, and when it reaches here, at that time obviously u sine alpha is, the velocity is again regained by it. Okay. So if I want to analyze all of these things and try to find out the dynamical quantities related here, so I have separate this two-dimensional motion along the x-axis and along the y-axis, the horizontal motion, the vertical motion separately, and we'll deal with this separately, and we'll consider each of these things separately as a one-dimensional motion. One is u cos alpha is along the constant velocity, no acceleration. U sine alpha is about the with constant retardation from here, and then after constant acceleration. So, and why you want to say this thing capital R, which is noted here, it is called the range. It is called the range. The particle along the ground, if we see along the ground, it will reach from here to here, it is called the range. So let us analyze the vertical motion and the horizontal motion separately, like this way. So here it is a throwing point, from it is throwing with the velocity u sine alpha, and it is moving upwards. When it is moving upwards, the velocity is positive but the acceleration is negative. So the positive velocity, negative acceleration, so retardation. So due to this retardation, the velocity decreases, and when it reaches here, the velocity becomes 0. So at first we calculate the case of ascent. After that, after a momentary rest, we just draw it separately to distinguish it separately, nothing else. But the particle is coming down. If I say the vertical, it will coming down along the same path, so it will be 0. Okay, after momentary rest, the velocity will be 0, and then it is again coming down, and we have calculated this thing and we have proved this thing. The velocity of throwing and the velocity of striking, it will be same. Just see, it is a throwing point, it is the aim, it is not the same point on the ground, it is a two different points. It is a throwing point, it is the aim. Okay, this is a throwing point and this is the aim, two different points. So from the u sine theta, from here it is projected, it is a throwing point, it is here at x equal to 0, and where it reaches at the aim, it is at x equal to r. So these are completely two different points. And when it is coming down, we will consider the case of descent, that is coming down. Okay, so in going up, if it takes the t1 time, then t1 will be the time of ascent. In coming down, if it takes the t2 time, then t2 will be the time of descent. Then t1 plus t2 will gives us the total time of flight. So in case of time of ascent, I want to tell you that is v equal to u plus at. If I write down this equation, I just separate it, ascent and descent. So v equal to 0. Initial velocity is u sine theta. Initial velocity is u sine theta, obviously positive because it is along the positive y-axis, plus at, a is acceleration, that is minus g. The time taken by the particle to reach from here to here, it is t1, so it will be t1. So t1 is equal to u sine theta divided by g. Okay. Now, if I use another equation, that is v square equal to u square minus 2s, final velocity is 0 square. Initial velocity is obviously the plus u sine theta whole square plus 2. What is the acceleration here? Minus g. Okay. If the height achieved by it is the maximum height, obviously, and that will be capital H, then that will be capital H. So I can write down this thing as capital H. So H will be u square sine square theta divided by 2g. This is the maximum height attained by the particle. So what I get if I want to try to understand from here, the maximum height attained by the particle, that is the capital H, we obtain u square sine square theta divided by 2g here, and the time in reaching the maximum height, that is t1, so it will be u sine theta divided by g. Now again come back here. In the case of descent, the time taken in the particle, let us consider t2, that is the time, t2 is the time of descent. Here the velocity is 0, and we have proved that when it strikes here, the velocity is again u sine theta. So we can see the final velocity is u sine theta, and that is along the negative y-axis. Along the negative y-axis is upward positive, so it is a negative y-axis, so we can say it is a minus u sine theta. V equal to u. What is the initial velocity? 0. 0 is the initial velocity. Acceleration, what is the acceleration? Minus g. Time taken by it, t2. So here the concept that is applied here, that is the negative velocity is increased due to the negative value of the acceleration. U is negative, A is also negative, so here the particle is accelerated, but here the particle is retarded. Okay, so here if I calculate t2, then it will be again u sine theta divided by g. So this thing also happens in case of the vertical motion of the particle when it is throwing just upwards. Okay, vertically upwards. At that time, the time of ascent and time of descent is equal, so this thing is also followed here. Okay, so what is the total time of flight? Total time of flight. What is the meaning of the total time of flight? That's the time for which the particle will be in the air. That is the particle starting from here, it moves here, reaches the maximum height, and again comes down and just striking the aim. The total time in taking this, it is the total time of flight. How can we calculate? Time of ascent plus time of descent. So it will be, just see, t1 plus t2. So it will be 2u sine theta divided by g. So we get the total time of flight, we get the maximum height. We get the maximum height. Here we get the time of ascent, and here we get the time of descent. Now you tell me, we're analyzing one single two-dimensional motion by separating into two dimensions. One is along the horizontal and this along the vertical. Now just look at here and tell me if the particle is actually executing this motion. So the time taken by the particle to reach here to here and again returns back to here, obviously the time taken by the horizontal component. Okay, the total time of flight that we obtain from the vertical by analyzing the vertical component, obviously it is same as that of for the horizontal component, because actually for calculation I am separating these into two-dimensional motions, into two dimensions, two separate dimensions, but actually these two things occur simultaneously. So when it is throwing and when it is received here or striking the aim, the total time of flight is capital T, and for this total time of flight, each and every point on it, the u cos alpha is always pushing it, in that direction, always pushing it for the total time of each and every bit of the total time of flight. So we can say, since along the capital X axis, along the horizontal motion, the particle is under constant velocity and no acceleration, because the acceleration minus g is acting perpendicular to that of it. This constant velocity will be u cos alpha, and this constant velocity is maintained up to the total time of flight. So if we multiply u cos alpha and capital T, so in that meantime it will be t equal to 0, it will be here. At t equal to t, it strikes the aim. It is a one-dimensional motion. If I try to make it separately, so it will be u cos alpha into t. It is u cos alpha, it is 2u sine alpha divided by g. So it will be 2 of u square sine alpha cos alpha divided by g. So the angle sine alpha, angle cos alpha. Okay, sorry, here I have just missed one thing. It will be no problem that the angle here I am theta and alpha is basically the same. Theta is nothing else. It is the same thing. Both here the alpha is basically the angular projection. Here I mistakenly write that theta. Basically I have to write alpha. So whatever be it, here is only one angle alpha. So if I write down this thing, it will be u square sine 2 alpha divided by g. That is u square, the velocity, initial velocity square, sine of 2 alpha, that is the angle of projection, divided by g. So it is basically depending on two things. The range, that is the r, is basically dependent on two things. It is number one, it is dependent on u square, the velocity with which it is projected, and number two, the angle, that is this alpha, or more or less it is sine 2 alpha on which it is projected. Okay, so this is the range, and when the range will be maximum, if I want to throw it at the maximum distance, just like here, if I throw it to the maximum distance, then at which angle we have to throw? Let us see. Now I am talking about the when r will be maximum. When r will be maximum. For r maximum, it will be u square divided by g. Okay, for r maximum, it will be u square divided by g. If u square divided by g is the value of the r maximum, because only one thing can vary here, that is the angle of projection, then the value of angle of projection for making the r maximum, it will be 1, because the maximum value of the sine function is 1. So it will be sine 2 alpha equal to sine 90 degree. From here 2 alpha equal to 90 degree, and from here alpha equal to 45 degree. So this is the two things. So if the body is projected at alpha equal to 45 degree, then for the constant value of the velocity of throwing, it will reach the maximum range. Obviously, lots of things remained here. It will be continued in the next video. Thank you.